Driving towards sustainability, unleashing the full potential of electric vehicles for a cleaner future. Electric vehicles are gaining traction as an environmentally friendly alternative to traditional internal combustion engine vehicles. This shift is primarily driven by the need to reduce greenhouse gas emissions and dependency on fossil fuels. EVs operate on electric power, significantly lowering the emission of pollutants such as carbon monoxide, nitrogen oxides, and particulate matter. This direct reduction in tailpipe emissions is critical in improving urban air quality and combating climate change. The role of renewable energy in enhancing the environmental benefits of EVs cannot be overstated. As the electricity grid becomes increasingly powered by renewable energy sources like wind and solar, the overall environmental impact of electric vehicles is expected to diminish further. However, the environmental benefits of EVs are not without caveats. The production of electric vehicles, particularly the batteries, involves significant environmental challenges. Mining lithium, cobalt, and rare earth elements needed for EV batteries often results in substantial ecological disruption, the extraction of which frequently includes water pollution, habitat destruction, and increased greenhouse gas emissions. Moreover, the ethical concerns associated with mining practices, including labor conditions and the impact on local communities, complicate the sustainability claims of electric vehicles. These factors necessitate a holistic approach that includes improvements in battery technology, recycling capabilities, and sustainable mining practices to mitigate the environmental downsides. Another aspect to consider is the life cycle emissions of electric vehicles, which vary significantly based on the source of the electricity used for charging. In regions where the power grid relies heavily on coal or natural gas, the environmental advantages of electric vehicles diminish as the carbon footprint associated with electricity generation offsets the benefits of zero tailpipe emissions. Therefore, the true sustainability of EVs is closely tied to the progress toward decarbonizing the power grid. Despite these challenges, the push for electric vehicles represents a critical step forward in transitioning to a sustainable transportation system. Addressing these interconnected issues requires a holistic approach. Driving a cleaner future, how electric vehicles and renewable energy are transforming urban air quality and sustainability. Electric vehicles present a promising solution to combat air pollution and reduce greenhouse gas emissions, primarily due to zero tailpipe emissions. Unlike gasoline-powered vehicles that emit pollutants such as carbon monoxide, nitrogen oxides, and particulate matter, EVs produce no exhaust emissions during operation. This is particularly beneficial in densely populated urban areas where air quality is often compromised by vehicular emissions, leading to respiratory illnesses and other health issues. By transitioning to EVs, cities can significantly improve air quality, enhancing public health and reducing healthcare costs associated with air pollution-related illnesses. This potential for positive change in our urban environments is a cause for optimism in the transition to sustainable transportation. Moreover, EVs boast higher energy efficiency compared to internal combustion engine vehicles. Electric motors are inherently more efficient at converting energy into motion, producing less wasted energy during propulsion. This technical advantage of EVs, along with the regenerative braking systems employed in many EVs that capture kinetic energy during deceleration and convert it into electrical energy, which is then stored in the vehicle's battery for later use, further enhances EVs' energy efficiency. This knowledge about the technical superiority of EVs can make the audience feel more informed and knowledgeable about the intricacies of sustainable transportation. The environmental benefits of EVs are further amplified when paired with a clean energy grid powered by renewable sources such as solar, wind, or geothermal energy. The transportation sector can significantly reduce its carbon footprint by charging EVs with electricity generated from renewable sources, which is a major contributor to climate change. This synergy between electric vehicles and renewable energy represents a critical step toward achieving sustainability in the transportation sector. However, to fully realize the potential of this renewable energy potential, the urgency and importance of transitioning towards a clean energy grid and expanding the adoption of electric vehicles on a global scale need to be stressed. This can make the audience feel the significance of their role in this transition. Beyond the drive, addressing the hidden environmental challenges of electric vehicles. While electric vehicles offer significant environmental advantages during operation, concerns persist regarding the environmental impact of battery production, particularly in the extraction of materials such as lithium and cobalt. Mining these materials can result in habitat destruction, water pollution, and adverse effects on local ecosystems. Additionally, ethical concerns arise regarding labor practices in regions where these materials are sourced. Addressing these challenges requires implementing sustainable mining practices, ensuring transparency and accountability throughout the supply chain, and promoting responsible sourcing of raw materials. Furthermore, investing in research and development to reduce the dependency on scarce or environmentally harmful materials in battery production is essential for a sustainable EV industry. The environmental benefits of EVs also depend heavily on the source of electricity powering the grid. If electricity generation relies predominantly on fossil fuels, the emissions associated with charging EVs may be shifted from vehicles to power plants. Therefore, maximizing the environmental benefits of EVs requires a concerted effort to transition towards renewable energy sources. Investing in renewable energy infrastructure, such as solar, wind, and hydroelectric power, is crucial for decarbonizing the electricity grid and reducing greenhouse gas emissions. By coupling the adoption of EVs with renewable energy generation, societies can significantly reduce carbon emissions and mitigate the environmental impact of transportation. Furthermore, end-of-life concerns pose another challenge in the sustainable management of EVs. Used EV batteries contain valuable materials that can be recycled and reused, but they pose a potential environmental hazard if not disposed of responsibly. Developing efficient recycling processes for EV batteries is crucial for minimizing waste and maximizing resource recovery. This entails establishing infrastructure for collecting, recycling, and reusing battery components and implementing regulations and incentives to encourage proper disposal practices. By addressing these end-of-life concerns, the EV industry can transition towards a circular economy model where materials are continuously recycled and reused, minimizing environmental impact and promoting sustainability. Driving towards a greener future, the transformative potential of electric vehicles in a sustainable world. The future of electric vehicles holds great promise, driven by advancements in battery technology and the transition towards renewable energy sources. With ongoing innovation, EV batteries are expected to see improvements in key areas such as extended range, reduced charging times, and minimized environmental footprint in production. These advancements are crucial for enhancing the appeal and practicality of EVs, making them more competitive with traditional internal combustion engine vehicles. As the electric grid increasingly relies on renewable energy sources such as solar, wind, and hydroelectric power, the environmental benefits of EVs will continue to grow. By charging EVs with electricity generated from clean sources, the overall carbon footprint of transportation can be significantly reduced, further bolstering the environmental credentials of electric vehicles. This transition towards renewable energy represents a pivotal step in achieving sustainability in the transportation sector and mitigating the impacts of climate change. However, to fully realize the environmental promise of EVs, a holistic approach is necessary, ensuring the sustainable sourcing of battery materials to minimize environmental degradation associated with mining and extraction processes. Responsible battery recycling practices are also essential to manage end-of-life batteries effectively and recover valuable materials for reuse. Furthermore, continued investment in clean energy infrastructure, such as charging stations powered by renewable energy, is crucial for supporting the widespread adoption of EVs and facilitating their integration into the transportation landscape. While the future of electric vehicles is undoubtedly promising, it requires careful navigation to overcome existing challenges and realize its full potential. By prioritizing sustainability at every stage, from material sourcing to end-of-life management, and investing in renewable energy infrastructure, we can pave the way for a cleaner, more sustainable transportation future. With concerted efforts and strategic investments, electric vehicles can significantly reduce emissions, improve air quality, and build a more environmentally friendly transportation system for future generations. Paving the road to a sustainable future, navigating challenges, and maximizing the potential of electric vehicles. The journey toward a sustainable transportation future powered by electric vehicles holds immense promise. However, it requires a comprehensive and strategic approach to overcome existing challenges and maximize environmental benefits. Advancements in battery technology and the transition towards renewable energy sources are driving significant progress in making EVs cleaner and more practical for everyday use. However, realizing the full potential of EVs necessitates addressing critical issues such as sustainable sourcing of battery materials and responsible end-of-life battery management. By promoting sustainable mining practices and implementing efficient recycling processes, we can mitigate the environmental impacts associated with EV battery production and disposal. Additionally, continued investment in clean energy infrastructure is essential to support the widespread adoption of EVs and ensure they are charged with electricity generated from renewable sources. Furthermore, a holistic approach integrating EVs into a broader sustainable transportation framework is imperative, including improving public transportation, promoting active mobility options such as walking and cycling, and optimizing urban planning to reduce car dependency. By embracing a multifaceted strategy that combines technological innovation, policy support, and public engagement, we can accelerate the transition to a cleaner, more sustainable transportation landscape. While the future of electric vehicles is undeniably bright, it requires careful navigation and concerted efforts to overcome challenges and realize its full potential. By embracing sustainability at every stage of the EV lifecycle and investing in clean energy infrastructure, we can pave the way for a future of transportation that is efficient, convenient, environmentally friendly, and resilient. With collective action and strategic investments, electric vehicles can be pivotal in mitigating climate change and creating a healthier, more sustainable planet for future generations.